So another subject is this hand row, right? So a few of you have instances of this where it's kind of like duplicate systems that are sort of layered into one another. So I'm going to draw like a quick diagram of what this system is in a flat pattern, and then we'll talk about it. But so basically, if you think about it in terms of a panel, right? These panels are unitized by two sets of panels, right? Because every two sets of panels has a sort of double post at the end. So that means that every panel is going to be, and I'm going to just draw this on top of the stringer, but something like this, and then it's going to have a double post at the end, and then it's going to have the subdivision in the middle. So it's going to have this then, and then it'll have your sort of light wires going across. Okay, that makes sense? You can see that here. So that difference is, what's the key to today's lessons? Repetition. Right, repetition. Thank you. So we're using the same things that we've already used. The only difference here is that now we're going to actually use sort of a combination of subdividing surfaces as well as constructing domains on those subsets of surfaces. If that makes any sense to you at all, it will in a moment. Or if it doesn't make any sense to you at all, it will in a moment. So right now I have a set of 4 panels, and I'm going to use those as a basis upon which to build that definition. So let me hide this pipe because I don't really want that anymore. Let's go kind of back to basics, and I'm going to start building off of something else. So we have these are the original subdivided surface. Okay, this is the original B-rep. The subdivided surface has been broken down into 4 panels. So let me kind of break this off into a new train of thought. So rather than breaking it down into 4 panels, what I'm going to do is break it down into 2. Why am I doing that? I know what you're saying. I know why you believe that, but that's not 100% correct. Okay. We're not breaking it down into 2 panels because those 2 panels are these 2 panels, right? And just for the sake of the video, we're not breaking it down into 2 panels because they are this panel and that panel. We're breaking it down into 2 panels because I'm trying to represent 2 overall systems of that, which has 2 subdivided panels each, if that makes any sense, right? So I'm basically translating these 4 panels into 4 panels of these, which means that each one of those sets of 2 has 2 double posts at the end. So they're basically 2 systems, 2 completely independent systems that we're building off of a subdivided, very long, very simple surface. So let's just reduce that number to 2 and get going. 1, 2, right? So now you have this really long rectangle that we're working with. Kind of looks like that overall system, right? So what do you think we do next? What is going to make this system look like this? What is going to make that look like that? I keep hearing you want to say something and then you stop short of actually saying it. You could be right. What's wrong with being wrong? All right, so I mentioned 2 primary tools that we're using. So, yes. It's the only one we haven't used yet in this definition because we've already divided the domain, and then we're going to construct a domain on that divided domain. Cool thing is I've already got it built, so I can borrow this, take these 4. Actually, is it going to be even? Yeah, it is going to be even. Let's just take the whole thing because they're centerized. Copy, paste, and then plug this guy in. Boom. Turn that on. turn this off, and there it is. It's already done. If you really want to be strict about it, I think this 0.01 can actually be a 0 because it's going the full height top to bottom. You know, whatever, semantics. All right, so that is the basis upon which we're going to build each of these systems now. So now what do? We have, where's my good marker? We have this and this. Right? So what do we do next? It's a good choice because it's one of two choices, but unfortunately it's the incorrect choice. So what do we do next? No, that's the same thing. Isotrim is divide. Yeah. What do we do next? Really? I said there are two choices. So we have these two primary things that we're doing. We're doing divisions of surfaces and reparametrizing them using construct domain squared. Very close. I know what you meant to say. It's construct domain squared. So basically we're doing the same thing we did in the last definition, but we're doing it again. We're using a double construct domain squared. So I'm going to grab this again, copy, paste, move it over, plug this surface into it instead, and look at that. It's already pretty much there. Right? You guys see the resemblance? This and that? I mean, I can exaggerate it for you so you really see it. There you go. So there's the original surface, there's this surface. If you really want to make it like, you know, super simple to see, let's, I'm just going to do this so you can visualize it, but I'm going to pull that over here, pull another one over here, and then throw on some curves so that you can see the curves, and hide this and that and this and that. Hide.
So look at that.
Look at that. That looks like that, right?
It's already there.
Now we have this. What's next? You stole Chance's answer. I was going to give him a chance to redeem himself after choosing the wrong one. Okay, so now we're going to divide. You guys. Okay, so we're dividing this now. So we've got the middle surface is the one that we want to divide because that's going to be the one that we're going to create the horizontal pipes on. So let's go back to, we can actually just copy this too. So that's like copy, paste, copy, paste, copy, paste, right? That's all it is. When you're working with quadrilaterals, it's actually really, really easy to do that. So plug this in here, plug that in there.
And you're going to want to reparameterize that one.
Why is this grouped? Why is that broken down? Graphed. Ah, there we go. I know why. So this thing was creating, notice how it was creating one on the right and one on the left.
Right.
You know why that is? Probably don't. I'll just explain it. So basically, you have this surface, which is creating like a singular surface in a singular list. So it has 0 says it's the left surface, 1 is the right surface. So when you divide that, it divides the left surface, and then because the domain divide is grafted and it comes out in default that way, it's going to do the left surface on the left side and then the right surface on the right side. But we don't want to do that.
So it was grafted.
Yeah, so you can graft it this way, which is an easier way of doing it. And that just creates like a separate, see that n equals 1? I explained this to you a couple times before. I expect it to be something that you're getting familiar with, but I do anticipate that you don't have a full working understanding of what that system is yet. That is a tree, a data tree. Those are two branches of that data tree. So now it's saying, I want to take the first surface and I want to run this subdivide script through that first surface alone, which is 2 subdivisions, right? And then I want to take this other surface and I want to do that same operation to it again. Okay? So that's what that will do for you there. Hide that. So now we've got that subdivided surface. What are we going to do next? Oh, so close.
Oh, divide domain?
Yes, we're going to divide domain again because what are we trying to get?
We're trying to get the lines going across.
Yeah, I actually forgot. We already have these now. But now we want it. So that was what we just did with divide. Then when we divide it again, we're going to get what?
The lines going across.
Yeah, we're going to get these. Cool. That's it. And we'll do that one too. All right. So when we divide domain again, copy paste, plug this in, plug that in, and what do we have here? We have n equals 2. So in this case, I want to, this is getting a little funky, but because we already grafted it into 2 separate groups, right? And remember, a domain, this, is going to come out as a grouped data set, right? So it's basically saying I'm going to split it into like 4 subsections now based off of how many surfaces you're plugging in. It's a little confusing. But when you see something like this, when you're looking at the data trees and they're not syncing up and it's cutting data from you, flatten it and then regraft it into individual groups. And I'll show you what the difference is here. So this information is coming through in groups of 2, right? 2 surfaces are getting run through a subdivision, and then the next 2 surfaces are getting run through a subdivision. And the result of that domain is basically breaking down all 4 of those surfaces, but it's only doing the operation to 2 of the surfaces at a time. It's okay if you have no idea what that meant.
Wow.
It's really tough to understand what's happening. Yeah. As you experience it more and as you sort of troubleshoot through it and visualize it, as you're kind of correcting like grafting and flattening and all this stuff, you'll start to understand over time more intuitively. But anyway, take a look at that data. I'm going to go into set tree, and I'm doing this a little bit extended so you'll kind of see what's happening, but we're going to flatten the tree. Right, so now it's reading as 4 surfaces, not 2 sets of 2 surfaces. That's important. Then we're going to graft that tree. Okay, so let's take a look at the chronology of what we did. When we flattened it, it turned it into that. And then when we grafted it, it turned it into that. You guys understand the difference between those 3 lists, right?
Yeah.
Huh? They look and operate different, not just look different. So that's what you want, is what you see on the right, right? You want it to be each individual surface is getting operated on by that domain subdivision. So when we plug this one in, that's going to be the key. Boom. Now we have all those subdivided surfaces. So I also need to change the numbers that we're subdividing. So remember that this was 4 surfaces on 2 panels, right? So rather than subdividing it by 2 in this direction, I only want 1 in that direction, but I want like a bajillion in this direction. So when you turn all of this off, that's what you're left with. Let me turn this grid off. So that's what you get left with, which is the middle part. Okay? So let me see how we're doing on time on this video. All right, I ran a little long. But I feel like we're so close to the end that it doesn't make sense for me to do another video just to show you all the piping and stuff like that. Actually, I think it does, because the definition is actually square. Well, partially square. So let me go into a different video for that.
Why do you say it's partially square?
So like these are rectangular forms. So the way that you would operate on those is different if you want them to be precise, and that's the other chapter of what I wanted to teach you tonight was precision. So until now, we've pretty much just been learning like slap a pipe on there and get it to kind of look what it wants to look like, right? But at this stage, with your mastery of what you're doing, I can show you how to do things a little bit more precisely, like an exact size. What questions do you have? So I hope that that wasn't terribly overwhelming. It shouldn't be, because we literally did the same 2 operations that you've done all this time, just a whole bunch of times. So just to reiterate, we did subdivision, construct domain, oops, with a subdivision, and then there was a little flattening thing we did, and then another subdivision. That's it. That's all we did. Not intimidating at all, right?
No,
You guys are intimidated by that?
no way.
Okay. I know Juan isn't.
Yeah.
Okay.